My journey to microplastics started by doom scrolling on Twitter during the pandemic and needing to avoid reading about COVID nonstop. So I started following researchers and became very interested and fascinated with the complexity of microplastics. Microplastics are called a diverse suite of contaminants, and this is because not all microplastic particles are the same. A definition of microplastics, it's a small piece of plastic, less than 5 micrometers, which sounds simple, but it's really not when we think about that definition in more depth. So different types of microplastics can be the different shapes that plastics break down to. So you can have fibers, you can have pellets, you can have fragments. And microplastics are made of different polymers. So this can be polystyrene, polypropylene, polyethylene, any polymer. Microplastics are typically 1 micrometer to 5 millimeters, and anything smaller than 1 micrometer falls into the nanoplastic category. And so because you have such diversity with different microplastic characteristics, this makes it really challenging to understand fate, transport, and toxicity. Because microplastics are so widespread, we see a lot of different markets potentially being impacted. So this could be chemical manufacturers. It's also stormwater management. It's agriculture. It's wastewater. It's industrial water. It's food and beverage. There's a lot of different markets that we think could be impacted. And we're working with some clients right now to help them with their challenges with microplastics, looking at process engineering for industrial water to prevent the release of microplastics into the environment, and looking at food and beverage packaging to eliminate microplastics from food and beverages. And this is why it's really important for us to stay at the forefront of this technology and follow the state of the science and the regulations to be able to predict these trends and understand where the science is going.